Next we have Dr. Helge, who will tell us about the futures of the roof. I know some of you are building houses, so keep a close attention. Maybe you will need Solrif too, also. Everybody needs it, but for personal use, for the customers, for everyone.
Maybe you can hand it to the audience then after. Okay, thank you very much for inviting me here for the conference. I will talk about the Solrif system, and I will redirect from the agri-PV to another application that also has in mind to use existing surfaces, because agri-PV is basically about using agriculture and then using it at the same time for PV. And we are talking about roofs now and using it at the same time with a sustainable attempt for PV construction. My name is Helge Hartwig. I'm working for the company of Schweizer. And the company of Schweizer is based in Switzerland. And it's a coincidence. The name of the country and the name of the family, it's a family-owned stock company, is the same. So it keeps in the mind. You can remember that. And to show a little bit around here, the idea of the Solrif system, so we are a supplier of mounting structure to SoliTek. They are touching the mounting structure to their modules, and the module works like a large surface roof tile afterwards. And we had a small sample here. I don't know, he's already okay. Been given around. So basically you have the module and you have more or less the mounting structure here at the module. And with that, you can handle it like a roof tile. So it's a very easy attempt. Let's see if it works here. So is it the arrow or forward? No, oh, this is forward. Okay. Okay, so the title of my presentation is Roof Integration, the concept for modern design with manifold range of applications. So basically, I want to draw your attention. That's a very easy thing, and it's a sustainable thing to use those tiles instead of tiles plus PV. And at the beginning, I will say a few words about the company of Schweizer, because I think nowadays it's important to know whom you're dealing with. Some more details about the Solrif system. By the way, the name Solrif is Solar Roof Integration Frame, and it was invented more than 20 years ago, so we have a lot of experience with that. Then a few words about planning and installation. I won't go into the details and bother you with that. It's more the attempt and the concept that I wanted to make attractive for you. And some projects, you will find a lot of information on our website or in the internet, in Instagram and wherever. So, company of Schweizer is now owned by Samuel Schweizer, the 4th generation. And his statement is, the building of the future is digitally connected, energy efficient, and a solar power plant. I think this is not a secret. It's common sense at the moment, and we try to push it even harder, using any surfaces that are available for PV. And it's the 4th generation, so the company was founded in 1920, and we are not a very small company. We are 450 people in the area of Zurich, so Switzerland. And we have 3 core competencies, yeah. So one is the building shell. So we are dealing with the building skin. We are developing facades, quoting facades. And when we get the order, then we are also producing the elements, windows and doors and everything is needed, or for other systems, adapting, and then we are mounting and also maintaining. So that's a very big business unit with doing large projects with several millions, maybe 5 projects, 10 projects a year, but with a high turnover. Then we have here a little bit strange, the letterboxes, but basically it started in 1920 with the letterboxes, and it's also a significant share. We're switching to intelligent boxes that are receiving packages from Amazon, for example, and you get a note on your mobile phone, and then you can remove the package in the evening. And then we have the PV mounting systems. Basically, the company started during the 70s with solar energy. We started producing solar energy collectors, but we are still doing that, but it's not the focus anymore, it's the PV mounting systems. And we have two types of mounting systems. On the left, you can see the common ones that everybody knows and everybody is using, I think, more or less, for flat roofs and pitched roofs and trapezoidal roofs and anything that helps to adjust or modules to roof. And on the right side, we have the roof integrated system. We started during the 90s with that, so we have more than 20 years experience. And the idea was really having a standard module from the market, adjusting this frame or adapting this frame, and then having high power output and everything like benefit that you have with those modules. So the idea behind is really it replaces the classic tile. You can put it directly onto the roof, on the wooden subconstruction of the roof. It's very easy to install. You will see how it is being handled. It's reliable and high quality, especially if the module is high quality. I mean, that's the key, I think. You have a much higher yield per square meter than, for example, with those small tiles where you have 4 cells laminated onto it or whatever. You know, there's a lot of variety in the market with different tiles working similar. It's proven over 20 years, and we have a software tool, web-based. I will have a few remarks onto that. So what you can see here on the left side is a roof with counterbattens or a membrane counterbattens and horizontal battens prepared for the Solrif modules. And on the right side, you can see basically a roof being prepared with tiles and afterwards installing modules above that. And this is not really the lean way of doing it, I think. It's much more effort, it's much more energy, and still we are used doing that, and just only because the interface is clearer. So somebody is doing the tiles, then roof is finished, and someone later, someone comes and installs the PV. So that's very easy to us, but now we get installing PV mandatory. We get the rules that we should install with constructing or reconstructing the roofs. So it doesn't really make sense to put first tiles and then modules. Makes much more sense to put the modules directly. And yeah, the advantages is much faster installation, only once, modules directly, less gray energy, so less material, and you have less weight, by the way. And the big benefit is the superior design. It looks much nicer if you have an integrated solution on the roof. We have several additional advantages here with the Solrif system. For example, I will focus only on a few aspects, that the module is lying on the lath and the long side of the module is being supported by the lath, and statically that's much more, it's much better than just punctual support with clamps and things like that. Then it is basically an inlay system. So you put the clamps and you lay the module into the clamps, and then the module can move. Every module can move itself during expansion and compression or temperature raise and decrease. It can move, so there's no stress on the modules. That means you don't have any damage there. It works really fine there. And yeah, there's some figures here for the weight. If you have, for example, 15 kilogram per square meter with a glass module by SoliTek, then you would have 15 plus at least 30 kilogram with a tile on the roof. So that's a big difference and might make the difference, might be important. Then there's an additional feature. We call it a 7/8 frame. So if you see a little bit closer, there's a second sample. Maybe you want to have a look and give it to the others. Oh, maybe everybody saw it already. So you have no frame on the bottom. That means you have a much better self-cleaning effect. So water, rainwater that's coming down is washing away the dust and everything. With agriculture, maybe, yeah, if you can switch it, then dirt is also being washed down, but here with the free lower edge, you have the same effect here. Yes, and just to show how it is being installed, you have those different small clamps here. See it here? 3 different types. We have samples here as well. So module plus those clamps, that's a mounting structure. You basically don't need much more. And you need to put as much clamps as are needed in your certain circumstances statically required. So you have 1 clamp at the interlocking parts of the modules and additional clamps in the middle. And the calculation gives you the number that has to be placed. And we have this little tool here that is helping to place those clamps. Oh, so that didn't work. I don't know. To start the movie here, maybe here. No, that's a touch screen. But this is yeah, that's the movie. But it doesn't work. So that's. Oh, I cannot start the clip here. So basically, the clip that is not starting now is showing that it's really easy with this tool. You just put it. I have to be careful. I don't. You put it here on top of the module, for example, and you lay down. Yeah. So it's very easy. You put the tool there, put the number of clamps that is required into the spaces of the tool, and you fix it with screws. And so you go on module by module. So the installing is simple as it can be, much easier than the on-roof installation. So I think the mounting itself is without question much easier. So from my point of view, challenge is the coordination of those craftsmen, different craftsmen that are building a roof. So first, we have the carpenter who is doing the wooden substructure. The substructure is completely identical if you put tiles afterwards or if you put modules afterwards. That doesn't make any difference. Then you need someone. You need someone who's putting the modules and connecting them electrically. And you need someone who is closing the roof or the leftovers of the roof. And you might need a tinsmith who is doing some connecting details. And you have to coordinate. It depends on the configuration. If you, for example, covering the roof completely, then the tinsmith has to come first, have to do the flashings on bottom and on left, on the right, and then you put the modules, and afterwards he has to finish on top. So that's things that might complicate that a little bit. And I think the challenge is the different craftsmen, they have to talk to each other and they have to find a solution how to easily install it. That might be a little bit more offending, but it's something that architects, for example, do always. They coordinate the people who are building the building, and then it works fine. And if you have a little bit of experience, then it's very easy to do. Our approach is now to supply standard flashings here. Basically, we are supplying to SoliTek, and SoliTek is able to provide the complete package. And there we have a standard solution to connect between the modules and the tiles. We have some top flashings, we call it ridge flashings, some interconnections, bumper flashings, and so on. And side flashings, left side and right side. And with it, you are able to put the modules onto the roof with all the flashings. Then the PV installer is off, and then the roofer comes and covers the roof with the tiles, as it is always with him. So there's nothing different for him. And we extended this range here to cover a bit more of possible shapes here. On top of the roof, we added some flashings for the inner corners here. So on the right side, you can see 4 different types of inner corners. And basically, it's done by a little bit smaller side flashing and a little bit smaller ridge flashing, and then with some interconnecting parts. You can have a left corner on top and a right corner on top. And on the bottom as well, you leave away the flashing profiles, and you have a certain flashing that is connecting here in the inner corner. So the idea behind is really to provide standard solutions, put it onto the roof, and then the roofer comes afterwards, so the craftsmen know who is doing what. And if it's closed afterwards, it looks like this. And on the construction site here, it's a triangle-shaped roof, and you can, by the way, see that you can also shift rows against each other. And then you have standard solutions for those corners. And with those black tiles and with covering the remains with the black tiles, you might have a really nice homogeneous view of that. And it makes it easy to do one after the other. So the idea basically is carpenter is preparing the roof. The solateur or electrician is placing the modules. And afterwards, if there are any leftovers, then the roofer is putting a few tiles to complete the roof. And you don't need the tinsmith anymore. So I think a lot of challenges occurring here are linked to the shape, different shape of the roofs. And the mounting itself is really easy, and the planning process, that's something you have to have in mind, and where you might need a little bit of experience. But I think there's really a tendency of doing that more often. In Switzerland, it's a very common use to build integrated solutions. But for example, in Germany, it's not really common. We still try to push and to find partners and build up a network and so on. Just a few words about the software. I mean, basically, it's a web-based software, state-of-the-art. And you can choose location from Google Maps, and then you have the map for the wind load and the snow load, so picking the loads, very easy, and so on. You might draw roofs from Google Maps, so if you know the location and it's a retrofit, for example, then you can very easily draw the roof and have a load calculation, and then you have a CID drawing that shows you. CID drawing is the next picture. You select the module here, and then you get a CID drawing afterwards. So you can choose here between several modules. Basically, it's only important to pick the correct size. And you can, for example, see when SoliTek is increasing the power from 350, 355, 360. In terms of installation, it's always the same, and it's the same frame and the same concept of putting the modules on top. So that's a real big benefit that we are benefiting from the increased power there. Yeah, and as a result, you get the CID plan of the roof here with all the important dimensions. I mean, the most important dimension is the size of the generator here, horizontally and vertically, because you might have to shift it a little bit on the roof or make sure that there's sufficient space and things like that. So you have to keep that in mind. You have also the grid dimensions here, horizontally and vertically. So you know how to place here the battens, you know how to place the modules. And one very important feature is the blue clamps here, or the blue fixing points. is at the interconnection of the modules, and the glass ones, the additional ones in the middle, that's the yellow ones, is given by the program. By the way, we have here always 2 glass clamps, so it's very easy, but that might vary, that you have at the edge of the roof only 1 or even 3, something like that. But it's scalable, very easy scalable there for different load situations. Yeah, there are some brochures. You find it on our website. I don't know, Viljus, if SoliTek is also providing a branded version on your website, but there's some information. I have a few brochures with me. I will put them onto the table afterwards. The idea basically is here on the left side, the brochure for the end customer, so with nice projects, interesting him for that, and on the right side, it's for the installer, where you can see all the details for the mounting and the installation of that. So, a few projects here. There has been, that was the first larger project in Switzerland. On the left side, in 1999, was already a large installation on multifamily houses with small Kyocera modules. So it was, I don't know, exactly 27 or something cells, small modules. And in 2018, they added a new section of those buildings, retrofitted them, and installed here much larger surfaces and much more power onto the roofs. But basically it shows that they were believing into the system and using it again 20 years after. So we have, we are going quite frequently onto construction sites and helping people to do, if they do it the first time. So we see that there's a lot of projects being realized. That's one from Berlin here, with a dormer and completely covered everywhere. And working with so-called dummy modules here around the windows. So we have a Solrif framed metal sheet, and you can cut that, and you can have the flashings and the interconnection, and then it looks very homogeneous and is very easy to install because everything is standard then. Yeah, something here, retrofit. I like that because it's an antithesis here between old and new. So an old farmhouse and retrofitting the barn here, that looks really nice, and it has been completely covered as well, and also with dummy modules filled. Yeah, same thing here, very homogeneous, dark surface. I don't know if you can see that, but also being dummy modules installed here on the bottom with a different size than the other modules, making snow that's sliding down, not shading the modules, and filling the roof, so the remaining surface here. Then something that's coming up is colored modules as well, so there's a lot of requests. There's different technologies of coloring modules. Here it is ceramical printing on the glass. For sure, that makes a difference, so you lose a lot of power. But sometimes in monumental protected areas, it's more important to keep the color, and it's still producing energy. So yeah, that's a trend we can see, especially if we want to cover even more buildings everywhere. You can see also glass being framed with Solrif, so you have a little bit skylight there in those sections. And you can also see here a snow barrier that's being put on so-called dummy modules. Yeah, I think basically the direction is going on to covering as much as possible. I mean, that's always depending on the technology below and on the circumstances here and the feed-in conditions and so on. But basically, we want to generate as much power as we can do. And here on the right side, for example, we have a storage as well, a hydrogen storage. And the owner said, I want to provide all my demand in electricity and also 15,000 kilometers a year with my electric car. So he put a 900 kilowatt hours hydrogen stories there. It's a little bit weird, but basically I think shows the tendency. Yeah, same thing here. Oh, movie doesn't work, sorry. So we would see different views of the roof, because basically three of those four roofs are being covered completely with the solution here, and only the north-facing roof is with sheet, common metal sheet. And very special here is that they built also dummy modules here for this section of the roof, and they put cells just to make the same view, which is much effort for just a little bit of appearance or better appearance. Yeah, sorry, the movie here is also not working. You only see here a little bit remains of the roof. It's inside Stuttgart, the town hall, and underneath is the Ministry for Energy. And they put here an integrated solution onto the roof. It's 90 kilowatts, so it's a large installation. And the reason, or the argument was basically that the roof would not bear tiles with PV, so they had to replace the tiles with the PV directly, which is a good argument. Yeah, also a roof near Munich, where you can see everything that is manageable with a solution. And yeah, as you might imagine, it gets quite challenging here, because you have to solute a few details, but it is possible. And if you have good workmanship, then it's no problem, basically. So on our website, we are collecting those details just as a proposal for someone who has similar boundary conditions and wants to cover the roof completely. And we collect it here, for example, for the roof eave, when you go directly into the drainage on the bottom, you don't have tiles there, how you can handle that, or how you would do a ventilated ridge. Or here at the verge or roof valley, so we are collecting there a lot of details if someone has to find a solution there. He can check our website and get the drawings. So there's a lot of information on our website, www.solrif.com, and it's arranged a little bit here for the decision maker, so the one who is deciding. And from our point of view, there's very often the customer who says, I want an integrated solution. It should look very similar to what I've seen. And then he needs a planner who's doing it for him, and an installer as well. And that's the value chain where we try to connect everybody with everybody and build up a network, especially in Germany, because we think there's a big potential there. Large market and only a very low share of integrated solutions. Okay, that's basically my statement for the roof integrated solution in cooperation with the SoliTek modules. Are there questions?
Thank you for the presentation. It was really impressive. I have a few questions regarding the water management and what is the slope of the roof. It's not so big, so it's low slopes. Usually in Cyprus we have low slopes. And what's about the water management, the leakages and so on?
Yeah, thank you for the question. I mean, basically, it's totally the same if you have tiles or if you have those modules, because we are talking about a standard roof pitch, and that has been tested. And for the system, it is 22 degrees. And that means above 22 degrees, it works really fine. And below 22 degrees, you need to have additional security. So, for example, the membrane underneath being glued and not only laid overlapping, and so on, but then you can go down to 10 degrees. But one thing is the 22 degrees is very important, because above it's very easy, and below you have to be a little bit more careful. But the ruler's instructions, they tell you exactly how you handle that in that case. And that means if you have overflow, because with tiles you might have that as well, then it's dropping onto the membrane and then being driven out of the construction. So nothing happens to the roof, basically. So that's the concept, and you need that also for condensation, because you might have a lot of condensation on the back of the modules dripping down in the morning after being very cold in the night.
Two things. Is there any space for ventilation of the modules and to installing, let's say, the power optimizers if you're using Solrif? Is there any space underneath the panels for that?
The answer is very simple, yes, 2 times. No, I just wanted to go back to the picture where you can see the construction with the counter buttons and the buttons. So you at least have this ventilation space here in the region of the counter buttons and of the buttons. So in Germany it would be typical around 6 centimeters, something like that, but it's a totally standard for roofs like that. And you can fix those to the LAS, the optimizers there in the space, and it's being behind the module, so protected by weather. Mm-hmm. Yeah.
Thank you very much. I have 2 questions. Normally, you can step on a tail. Can you step on a panel? And the other question is only for a string inverter or also for a microinverter?
Yeah, so basically that was the question with a microinverter. If your microinverter is fixed to the module, then you can use it as it is. And if you have an optimizer there, you can fix it somewhere in the space in between. And the other question was if you are allowed to step onto the modules. And that depends a little bit on the module. Normally the module manufacturers, they don't want you to step there because you might get micro cracks in the cells. So better not is my answer. I know that sometimes they are doing that, or they are stepping onto the profiles at the interlocking sections if they need to get up there very rapidly, then sometimes they do, but better not, because that might be a problem then with the warranty of the modules.
Better not, but 10,500 pascals. Maybe you can. Additional questions? No? So thank you, Helge.